So we'll be finding the domain of functions. In particular, we'll be doing rational functions where the x is also located in the denominator. So to find the domain here, we're going to set the denominator expression 4 squared minus 9 equal, or should I say not equal to 0, because once this becomes 0 in the denominator, there will not be a solution, or there will not be a term. So this is the difference of two squares, so I'm going to factor this into two linear binomials by taking the square roots of the 4x squared and the 9. And I will get a 2x and a 3. Now we're going to take these and place them as conjugates. A binomial that has 2x plus 3 and another binomial that has 2x minus 3. Those are conjugates, and set them both not equal to 0. Then I want to solve them individually as linears. So 2x plus 3 not equal to 0. We'll solve for x there. And 2x minus 3 not equal to 0. We'll solve for x there. Let's kind of split the problem here. So subtract 3 from both sides, and we'll get 2x not equal to negative 3. And we'll take our 2x not equal to negative 3, and we'll divide by 2 on both sides. And we'll get 1x cannot be negative 3 halves. Let's solve another side. Let's say plus 3 here, plus 3 here. And we'll end up getting 2x not equal to positive 3. We'll take our 2x not equal to positive 3 and divide both sides by 2. And we'll get 1x cannot be 3 over 2. So these are the two numbers that we cannot use for x in the input. So that's the number system that omits negative 3 halves and omits positive 3 halves. So these two numbers are omitted. But we can use any number here on the left. So the domain, we can have negative infinity to negative 3 halves without using 3 halves. And we can use anything here in any number between, which is from negative 3 halves to positive 3 halves. And we can use anything to the right of positive 3 halves, which is 3 halves to positive infinity. And this will be our domain for this function. Now, what will be the domain for this function? This function, we have a trinomial in the denominator with the x, which is x squared minus 9x plus 18. And we don't want this, again, to be 0. So I want to factor this into two binomials, and they'll be linear binomials, and we can solve them as linears. So for x squared, that can factor into x times x. Now 18, we have lots of choices. There's 1 times 18, there's 2 times 9, there's 3 times 6, there is 6 times 3, there's 9 times 2, and there is 18 times 1. Lots of choices. I'm going to choose the 2 times 9. Okay. So 2 times 9, and then we'll get 2x here, and we'll get 9x here. And no, that won't work because I need to get an 18. So that doesn't work. Let's try 3 times 6. So let's start over. Because again, say if we use same signs here, we're going to get a negative 11x. That will not work. Okay, and negative 9x. So x times x. And let's try 3 times 6 this time. And this will give us 3x here. And this will give us a 6x there. And we use same signs, and yes, there we go. There's our negative 9x. So we found it. So we need a negative here, a negative here. So we can split this up into two pieces. X minus 3 not equal 0, and x minus 6 not equal to 0. And when I solve for x here, I add 3 to both sides, and I get x cannot be 3. If I add 6 to both sides here, I'll get x cannot be 6. So those are the two numbers we can't have in the number line. So Let's remove those two numbers from the number line. Let's see. I'll draw my number line here. There's the 3, there's the 6. Can't use that number, can't use that number. But we can use anything over here. So I'm going to say the domain can be negative infinity to 3. We use any numbers for there. And we use any number inside here. That would be from 3 to 6, unioned. And then we can use any numbers right here in this section. That's from 6 to positive infinity for the domain.